Okay, to wrap up passive transport, we are going to be talking about osmosis. The title slide here, this is actually the lead character to a movie, Osmosis Jones. If you ever have some free time, go ahead and check it out. So, where have we seen osmosis? Well, if you ever had a sore throat and a family member said to gargle salt water to ease some inflammation, if you've ever put salt on a slug, or if you've ever watered a plant. Plants need water. If you water them too much or water them too little, you're going to have drastic effects. So osmosis is diffusion. Passive transport, we are specifically looking at where is water moving. With it being passive transport, we are going from a high concentration to a low concentration. And remember the concentration gradient going from high to low. We do not need any energy to make that happen. We are going with the gradient. We're going down the gradient, high to low concentration. We have three types of solutions that comes with osmosis. We have isotonic, hypotonic, and hypertonic. Remember, a solution is made up of two things, a solute and the solvent. Remember, water is the universal solvent. So anything that it dissolves is the solute. If you are making lemonade mix and water, the lemonade mix would be solute. If you are mixing sugar and water, sugar would be the solute. If you're mixing anything, water is always the solvent. As we see here, we have three different situations. The hypotonic, it looks like it is getting bigger because we primarily see water going into the cell compared to leaving the cell. The isotonic is unchanged. So we see water coming in and leaving at the same rate. And hypertonic, should I say, with the E, it is shriveling up because we see water leaving. So it's actually becoming dehydrated. Now with isotonic, just as we saw, water is coming in and leaving at the same rate. So if we look at two sides of the cell, if we have, say, 50% salt and 50% salt, that means our water concentration is also going to be the same. So what this leads us to is water is leaving and going at the same rate. So the shape is going to be unchanged. For all of our cells, this is the preferable solution that our body is in. An example of an IV or an example of an isotonic solution is an IV. If you need an IV, they're not going to give you pure water. Instead, they're going to give you an IV solution, which actually does have a lot of salt in it to mimic what our blood concentration is. Our blood isn't just made up of water. So we need to make sure that we have something similar to avoid our cells getting bigger or smaller as a result. Our next type is hypotonic. So once again, let's say this is the cell and this is outside the cell. Let's say we have 10% salt versus 50% salt. This would leave us with 90% water versus 50% water. What we're going to see is we're going to see a lot of movement into the cell, very little movement outside the cell. Because we see a lot of movement into the cell, it is going to swell and get bigger, blow up like a balloon. This is not good for animal cells. We do not have a cell wall as a protectant, so they could burst and die. However, this is ideal for plants. They have that cell wall, and creating a little bit of pressure adds more structure and support for the plant, plus they have that extra barrier to withstand any added force. Hypo means less. The key thing we're looking at here is there is less solute. If you have less solute, that means you have more water. That's what we see here. We have a smaller solute, which led us to a larger water concentration, water coming in. Our final one is hypertonic. So once again, if we have our cell, and then we have outside the cell, this is going to be the exact opposite. So if we stick with what we kind of been using, if we have 50% H2O and 50% salt, suppose we have 90% salt here and 10% H2O. The key thing we are looking at with osmosis is what is happening with water. That's the only thing we're really concerned with. Since we have more solute outside the cell, that means we have less water, whereas inside the cell we're a little bit more diluted. So the movement of water, we have 50 versus 10, water is going to primarily be moving outside the cell compared to going in. So whenever we see water going out, it is going to shrivel up. It's going to be dehydrated. Now, hyper means more, hyperactive. Hypertension is high blood pressure. What do you have more of? You have more solute, which means you don't have as much water wherever you're at. Within the cell, you don't have much water in the cell. Water diffuses still from high to low, so we see water moving out, causing cells to shrivel. This is not a situation that we want to see really in any type of cell. So we see a greater dilution in the cell. It's more watery environment in the cell compared to outside. It's almost like share the wealth. Water's moving out. So which of these diagrams at the right best represents the movement of molecules in osmosis? Water being the black dots, sugar being the bigger, whiter dots. Key thing to look at is we have to go across a membrane in osmosis. So right away that eliminates these two. Plus, we're only focusing on the movement of water. This is showing the movement of sugar. Osmosis is water. This is the only one showing water going across the membrane. These two are simply just showing, C and D just simply showing kind of them just spreading out, not really crossing anything to show a difference in concentration and trying to equal out. Now the final thing are just some experiments that have been done in class in previous years. You look at the celery, we do see that in a hypotonic situation that water came in, and you can kind of see that with the blue and the red here, that the dyed water is in the celery and didn't kind of plump up the leaves. Whereas in the hypertonic solution, the sugar-based solution, everything is all shriveled, dried up. It loses a lot of its support, and even the stalk is very, very flimsy, as you can see here, as well as down here, because it is becoming dehydrated. We also have the eggs. Putting eggs in a sugar solution, we are going to see a hypertonic situation. Vinegar is our isotonic situation. Tap water is our hypo. As you can see just by the basic size here, our isotonic one is pretty much the same size. This is a bit smaller, and this is much larger because water is coming in. For this one, water is exiting, and then we have water coming in and out of those two. You can kind of see, not the greatest picture, but kind of a side view of kind of the same idea. The key thing was dissolving the shell, so we show that cell membrane to allow things to pass. Our final one is our gummy bears. Same idea. From day 1 to day 2, we put it into a hypotonic solution, so it got bigger. From day 2 to day 3, I put it in a hypertonic solution, so this got smaller. You can see that in both cases. Water came in, and then once water left between these two. All right, that is it for osmosis. Let me know if you have any questions. Thanks for watching.